Our next speaker is Attilio. He's a senior software architect at TM. He will introduce us a new package in Julia today. It's about publish, subscribe, and remote procedure called middleware.
Okay, Rembus. Okay. Okay. Thank you. Thank you, everyone. Welcome. And my name is Attilio Donà. I'm working in the telecommunication industry, and I'm using Julia for my projects, for my enterprise project. But I wrote Rembus in my free time because I'm a Julia enthusiast. Okay. In this talk, I will make a brief introduction, a few necessary concepts to understand Rembus. Oh, excuse me. Yes. I will describe some few necessary concepts to understand Rembus. I will skim through the Rembus API. Sorry, ma vediamo così. No. Non so. Allora, ok. Let's try. Okay, I will describe the Rembus API, the three communication style of Rembus. I compared the Rembus with the Google gRPC frameworks, and I show you the fault tolerant aspect that make Rembus fault tolerant thanks to Visor, that is a Julia task supervisor. And finally, I will show you some a couple of demo with Rembus. Why another framework for distributed application? There are several reasons. The first is that it's written in Julia and it streamlines it integrates seamlessly with Julia code. It is easy to use. It's suitable for simple to very complex distributed systems, and it offers out-of-the-box support for Dataframes. A system that uses Rembus is made up of components and decoupled from a broker. The components are the processes where the implementation logic resides, and these processes are generically called components because they may play different roles inside the distributed system. Client, server, publisher, subscribers, or might be an application that implements many of these roles at the same time. Broker route messages between components, and messages are encoded with Cyborg. That is an ETF specification that offers a small code size, small message size. It also enable to integrate Julia with software with application written in other languages. Let's see an example of a published message on a topic called mytopic with a dictionary as a content. The total message size of this message is 17 bytes, for which 12 bytes are for application data, and there is a fixed size of 5 bytes as an header overhead. Let's note that the 5 bytes of the overhead, the header, remain fixed whatever entries you have in the dictionary, transported as a message content. And the Rembus layer on top of the Cyborg add only in 1 byte in the case of a pub/sub message, necessary to define the type of message transported. In this case, this is a pub/sub message. So I have talked about the topic in the previous slide. So let's focus for a moment on the concept of a message. Messages are classified into topics that might define their structure, semantics, and/or purpose, such as alarms, parameters, environmental values, computational result, or whatever else specific domain concept you have. So in a publish-subscribe system, for example, think the topics as the logical channel that transport messages of a given type. The message also is obviously characterized by its content, that is 1, 0, 1 or more specific values. So to understand Rembus better, simply think the topic maps to the function name, and the content values of the message map to the function arguments. So if you on the publish orco cane, sorry. So on the publisher side, you can call this function if you want to publish a message. On the component that declared interest into this topic, the metric topic, for example, you have to implement this function. So let's see for a moment the high-level interface. The high-level interface is composed of a set of macros that instruments the Rembus component. For example, if you want to publish a message for the metric topic, you prefix a function call with the publish macro that publishes the message on the metric topic with 3 values, a pressure, the value, and a timestamp, for example. On the component that is interested into the metric topic, you subscribe to the metric topic, and you have to implement a metric function that expects 3 arguments: the name, the value, and the timestamp. And the same is true for example, the RPC and the exposed service, with the only difference that an exposed service return value will be returned to the client that made the RPC request. On the box on the right, there are a set of lifecycle macros that, with the exception of the shared macro, probably have self-explaining meaning. For example, the component macro declares a unique name for your component, or the unreactive macro stopped the broker from sending all messages destinated to the subscribed topic, making the component unreactive. The shared macro, instead, is quite useful because it declares a shared object between all subscribed and exposed methods. And it might be useful, for example, to share an handle, for example, a connection database, a database connection handle, or to share an object that represents the global state of your component. We will see later in the demo an usage for the shared macro. So there are in Rembus 3 communication styles. One is pub/sub, publish subscribe style. One is the request response style, the classical RPC. And one is, I call it the conditional publish subscribe. So the first two, the pub/sub and the RPC, are quite standard. The conditional publish subscribe is a unique style of Rembus that is might be useful, for example, when updating all subscribed component with new status information when a remote component complete successfully a transaction to a database, for example. So the PubSub is the one-to-many communication pattern where one publisher produce a message, 0, 1 or more subscriber consume that message. The RPC, the request response pattern, is a one-to-one communication style when one client make a request and a server get back a response to the client. The conditional PubSub works as that. First, it starts with an RPC request to a server. The server, if responds successfully, the response go to the client, and the broker broadcast to all subscribed component the original request. So all the components subscribed are aware of the successful completion of a request. If the server instead returns an error, that is an exception, the broker does not broadcast the original request to anyone. Okay, let's see a brief comparison between, for example, gRPC, that is a Google solution for RPC, and Rembus. gRPC, as the name suggests, is dedicated to remote procedure call commands. So you have RPC, and also you have some advanced features like server streaming and client streaming, but it lacks publish subscribe. Rembus have both, and the combination of RPC and publish styles permits more complex pattern of communication. For example, a server streaming may be implemented with a combination of RPC and publish, for example. Or client streaming might be implemented with a publish from client side and a publish from server side. So how it works, gRPC? gRPC uses a Proto-C, that is a compiler, and a special gRPC plugin to generate code from client and server application. These stubs are then embedded into your application, and implementation are written in the target language that you have. For example, in the box there is the hello world example of a server called greeter, only the service definition, not the implementation, that expose a method, say hello, that expect a name and return a greeting. So let's see how it worked for Julia. So for Rembus, excuse me. Rembus, it's only pure Julia code. You don't need a compiler or a schema language or whatever else. You write Julia code, or the definition obviously and the implementation, and you embed your code with some macro to make it distributed. So this is the server definition and implementation, and on the right the client for the say hello method. So quite simple, I would say. Just to cite some other aspect of Rembus without entering into the details. You can make a client-server simple architecture without a decoupling broker if you want. You can set up private topics accessible only to authorized components. You can have anonymous, named, and authenticated components with a couple of RSA keys. Or you can make a custom broker if you want through an embedded a plugin that you where you write your logic. So one feature I'm excited to show you is the fault tolerant aspect of Rembus. When I started learning Julia a few years ago, I encountered this exception that prevent to do a controlled shutdown of the application. And it took me some time to understand how to manage this type of exception, leading to the conception of a visor. Visor is a Julia task supervisor that is heavily aspired to the Erlang supervisor model, and that permits to be fault tolerant to unexpected error faults, or for example also network exception, or whatever type of error make crash your task in an uncontrollable way, for example. So in the picture there are the tree of supervisor node that make up Rembus architecture, as we will see right now in the demo. So I will try to show you at least a couple of demo. The demo will be to demonstrate also the capacity of fast prototyping of Rembus. The demo will be in the interactive shell in the REPL. But remember that Rembus is designed to be a long-running for long-running application, not for the REPL, obviously. So I just start the broker in this REPL, and I show you in the meantime that it starts the code for the first demo. The first demo is just oh, sorry, ma come? Can you help with the? Non so se ho toccato qui. I touched here something.
I think your screen setup is duplicated, right?
Okay. Thank you. Then the first demo will be, for example, a DuckDB demo where we have an embedded DuckDB database. DuckDB is an in-process database that is not exposed to the external world, but it runs inside your application, and I will create just two API. A create that create the database reading some data from CSV file, pollution data. I have 3 files: Ancona, Atene, and Saragossa, downloaded from Kaggle. Another API to query the created table. Just make a select with a filter with the pollution element and a threshold. So let's start this application in another REPL. Okay, this is a RPC demo. Okay, so we have an in-memory database. So I will create some a table from Ancona. Here I have the database connection, then in the name of the file. Okay, if I want, I could query my table. Ancona. Let's ozone, for example, exceeding a threshold, and you get the first time of to plot. You get, for example, this data frame with the data from the station name of the Ancona that reports all the row that for which the ozone exceed 150. Obviously, this is local to this shell. There is no accessible for external because DuckDB is not a client-server database like Postgres, MySQL, or whatever else. But let's see what we can do with Rembus. So, with Rembus, to expose a service to remote client, how it works? It works like that. So, you have a connection handle that is obviously local to this process. So you have to declare that the first argument of your callback is a shared object, is the database connection handle. And you want to expose, for example, to the world, the query API. Okay. So, in another shell, let's start Julia here. Obviously, here you have not the query API, but the same thing you do here. You can make here using Rembus, first of all. So, if I want the same data frame in another data shell, this is what I desire, more or less. The database connection under is not. It's a local concept of the other shell. So the city, the pollutant, and the threshold value. Obviously, if you do this, it doesn't work because query is not defined here. But to resolve the problem, prefix with RPC. So wait for the first time to plot time, just a few seconds. Okay, too long. Okay, the first was too long and exceeded the timeout. But now you have compiled the code and you have here the data frame from the remote DuckDB database. So you can also try a much bigger data frame. It's quite instantaneous, obviously, now. And you exposed a DuckDB in memory data frame and in process data frame to the world. Obviously, if you want to see some other demo, you can, for example, unexpose your server, your service. Now, let's try. you get an RPC method unavailable exception because you have unexposed the service, but you can re-expose again, and you get again online the service. So it's quite dynamic on this respect. So let's see. And another demo interesting here, when I pass to the publish to Sky demo, is the possibility to interact with other languages, because the serialization of Dataframe, for example, is by Apache Arrow format. So you can you can use Python, for example. Okay, you can import the Rembus package. Here the API is pretty similar. So you can connect to the broker. And you can make the query. So here you have pandas Dataframes. You are happy to work in Python. I have no more time for another demo, or
We can reserve some minutes for questions, or you do the demo, but then we don't have
no questions.
questions. Okay. All right.
Sorry that.
Any question from the audience?
I saw ZMQ somewhere. You use 0MQ for something?
See, yes,
Okay.
there is a 3 transport protocol
Oh, okay.
on
TCP,
the bottom
0MQ.
layer. There is 0MQ, TCP, plain TCP, and WebSocket.
Okay. And
Okay.
did you benchmark? Done any performance testing?
Yes, but I'm not public result to go to show, because I was very concentrated to make a very simple interface. But the speed of the Rembus is quite interesting. But no, I did not find the time to make something, disclose something.
Very cool. Thank you.
Okay, thank you.
What other objects can you send? You can send data frames. Are there any other Julia objects?
You can send all primitive types. This is a cyborg specification, so integer, floating point, numbers, strings, binaries, data frames, because it is use Arrow, and this is the best you can do, because you can integrate with every language. But if you stay inside only Julia application, you can transport whatever type of structure you want, because you use the tag feature of Cbor. So you can define your struct, and you can transport whatever Julia object you want. But it's not optimized to encoding.
Okay, that's impressive.
Okay,
Thank
Arrow
you.
is optimized, but not your custom Julia structure.
Thank you.
Okay, thank you. Grazie.